first part of the SDK that we'll be talking about is the reference flash translation layer. This is responsible for mapping logical addresses into physical locations within the Ceph unit itself, as well as controlling all maintenance functions within the Ceph unit. Typically, applications interact with storage by going through the operating system. In this example, we've shown what it takes for a Linux application to submit an asynchronous I/O request to the system. First, it defines an asynchronous I/O control block, initializes it, and then submits a read operation in this case. So the application is interfacing with the operating system. The operating system is then interfacing with the device, which traditionally has had its own internal flash translation layer. With software-enabled flash, the picture changes slightly, but the concept overall is the same. Applications now talk with the reference software development kit FTL directly, and that in turn talks with the Ceph unit. Programmatically, this looks very, very similar. You define a context for the operation and initialize it, and then you submit the operation to the Ceph device. The reference FTL makes it easy to convert existing applications. It's a simple matter for normal I/O, read and write conversion. And the reference FTL is provided in full source code and highly modularized with separate modules for logical to physical address translation, superblock management, garbage collection, metadata persistence, as well as instrumentation for both telemetry and debuggability. You can use the reference FTL as is, or extract pieces and design them into your own custom FTLs. As Eric's mentioned, Kioxia was actually the inventor of flash memory, and we're leveraging our years of experience delivering both flash memory and solid-state disks to deliver a world-class reference FTL. It's fully lockless in its implementation, it's fully multi-threaded, and it takes advantage of all the software-enabled flash offload capabilities built into software-enabled flash. Using the reference FTL, you can experiment with all the different latency controls within software-enabled flash. So you'll have control over die time waiting, you'll have control over maintenance tasks such as garbage collection, control over provisioning for your storage, as well as control over data placement for both isolation, physical isolation of workloads and data, as well as write amplification. The benefits of the reference FTL are that it enables a fast transition to software-enabled flash. It's highly configurable to meet specific application needs, and overall, the goal is to reduce time to market with new and innovative storage solutions. You can use the FTL as delivered, or once again, you can customize the FTL using the source code that's supplied to create new application-specific flash translation layers for your own storage needs.